Hello everybody. Today I'm going to go over the investigation that you did in class with the sub today. Step 1, use your calculator to create a table for y equals x to the 1/2 at integer values of x. Record the data in this table. So on the right side here you can see that I already have the equation in my calculator. I'm going to go to the table, second table, to take a look at what we see. When x is 0, y is 0. When x is 1, y is 1. Interesting. When x is 2, y is 1.41, approximately. When x is 3, y is 1.73. When x is 4, y is 2. And when x is 5, y is 2.24. So the question says, when is x to the 1/2 a positive integer? So we want to look at the table that we see here, and we want to look at the y column. They want to know, when is that column a positive integer? That occurs at 0, 1, and 2. So x is a positive integer. Y is a positive integer when x is 0, when x is 1, and when x is 4. I would anticipate that we'll get another positive integer for y when x is 9, 16, 25, etc. So basically it appears as though the x's, when they're perfect squares, the y's are positive integers. So it appears as though x to the 1/2 is another way of saying the square root of x. Let's confirm that as we move on in the investigation. Step 2. Graph x to the 1/2 on your graphing calculator. So I already have it in y equals. Let's press zoom 6. Take a look at it. And it looks a lot like that parent function that we learned earlier this year, the square root of x. Okay, the square root of x graph. And this graph appear to have values at 0, 0, 1, 1, 4, 2, and 5, 6, 7, 8, 9, 3. So it looks a lot like the square root function, and that's basically the big idea in this investigation. They want me to make a conjecture about what other function this is equal to, and I've been saying that it looks like the square root of x. So let's put the square root of x into y2. And let's go over to the left side of the y and change it to a bold curve, and just make sure that our conjecture is true, that y equals x to the 1/2 is equivalent to the square root of x. State what you've discovered about raising a number to a power of 1/2. I've discovered that if I do something like 36 to the 1/2 power, it's the same as the square root of 36. I'm going to use this as my example with my statement, and we can see if I go to a blank screen, we all know that the square root of 36 is 6. Let's just confirm that 36 to the parentheses 1/2 power is also 6. All right. So we appear to be right on board here. Hopefully this is what you guys were discovering in class today with your teammates. Clear the previous functions and make a table for y equals 25 to the x power. I'm going to go to y equals and clear those out. And they want me to graph or take a look at 25 to the x. So now the exponent is the variable, 25 to the x power. And it says, let's let x go up by 1/2. To do this, on your calculator, press second table setup. That's above window. We're going to start our table at 0, but we're going to change our table, that little triangle there, delta table, we're going to change it by 0.5. So if I now go to table, you should see that 0.51, 1.52, our table goes up by 0.5. Let's go ahead and record this in the table. 0.51, 1.52, and 2.5, and it looks like I'm getting 1, 5, 25, 125, 625, and 3125. Okay, record the data in this table, so that concludes step 4. And let's see what they want for step 5. Study the table and explain any relationships you see. Okay, let's see. Relationships that I see. We have 25 to the 0 being 1. And we learned that anything to the 0 equals 1, so that makes sense. 25 to the 1/2 power is 5. Well, we just learned that the 1/2 power is equivalent to the square root. So the square root of 25 equals 5. Yep, that seems to make sense as well. 25 to the 1st power equals 25. Anything to the 1st equals itself. That seems to make sense. Let's go down to this one. 25 to the 2nd power is 625. It's just 25 squared. That makes sense as well. Let's focus on this one. 25 to the 1.5. If we consider 1.5 as a fraction, that fractional exponent would be 3/2. So 25 to the 3/2 power is coming out as 125. One way to think about this, what if I broke up 25 to the 3/2 like this? What do you think about this? Is that legal? Changing that 3/2 to 25 to the 1/2 cubed. 25 to the 1/2 power and then cubed. Well, think about that. If we had a power to a power, what would you do with those exponents? You would multiply them. We learned that earlier this week. 1/2 times 3 is 3/2 or 1.5. So that breakdown seems to make sense. So the 25 to the 1/2 power part that we have in here, 25 to the 1/2 power, that's going to be the square root of 25, which is 5. All right. So that turns out to be 5. So that comes out to 5. And then we're going to cube it. Well, if you take 5 cubed, you get 5 times 5 times 5, which is 125. So it seems to make sense when you break it down like that. 25, the next one, 25 to the 2.5 power. Let's explore that briefly. 25 to the 2.5. That's going to be the same as 25 to the 5 over 2, which would be 25 to the 1/2, then to the 5th. Well, let's see what happens when we go to our calculator here and take 25 to the 1/2 power, and then take that answer to the 5th. So it looks like the denominator there, the denominator 2, has you do the root. So we do the square root of 25 and get 5, and then the numerator becomes the power that you raise that to, and you get 3125, which is the answer. Next. In step 5, they want us to think about how we could find 49 to the 3/2 without a calculator. So if we do that breakdown, 49 to the 3/2, think about it as 49 to the 1/2 cubed. Well, 49 to the 1/2 is the square root of 49 cubed. So that's going to be 7 cubed, which I believe comes out to, let's just check, 7 cubed is 343. So I was thinking 43. Let's see if we get that same answer if we raise 49 to the, parentheses, 3/2 power. 343. Got it. How could we find the value of 27 to the 2/3 without a calculator? All right, so here's what we're getting at. 27 to the 2/3. The 3 tells you what root you're going to take. The numerator 2 tells you that you're going to take that answer and square it. So cube root of 27 is 3. 3 squared is 9. Check it on the calc. 27 to the, parentheses, 2/3. The powers in the calculator are going to go ahead and cube root 27 and then square it. 9. Bingo. Got it. Right there, 9. What about 8 to the 5/3? I'm thinking 8 to the 5/3 is going to be the cube root of 8. Cube root of 8. Sorry, that little 3 should be there. The cube root of 8 to the 5th power. Cube root of 8 is 2. Take it to the 5th power. You get 32. Sorry about that. 32. Double check it on the calculator. What were we doing there? Sorry. 8 to the 5/3. 8 to the parentheses 5/3. Bam. 32. Got it. Describe what it means to raise a number to a rational exponent. and a general procedure for simplifying a to the m over n. Here we go. Lo and behold, a to the m over n equals, the n is the root that you're going to take. Oops. The n, as in Nancy, is the root that you're going to take, and the m is the power that you're going to take it to. The nth root of a to the m. By the way, just so you know, the order doesn't matter here. You could take a to the mth power, then take the n root. These are equivalent. It's typically easier to do it this way, though, to take that number and break it down, and then expand it to a larger exponent. All right, that concludes the investigation. If you have any questions, please post something to the discussion blog or let me know in class tomorrow.